Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 3, Section 6, Lines in a Coordinate Plane. So a lot of this section, or all of this section, is a review of Algebra 1 and different forms of a linear equation. So if you feel you're very comfortable with those, you might want to just go through and make sure you have them written down and take a look at them. But I would like you to pay close attention to the standard form. One of the things I've noticed in years past is students think standard form is pretty useless and don't see the usefulness in terms of graphing. So I am going to go over how you can graph from standard form, and it is a very useful way to graph an equation, so you might want to pay close attention to that part. Okay, so the first we have is slope-intercept form. This is our y equals mx plus b. In order to use this equation for a linear equation, it has to be solved for y, and then the coefficient of x is our slope, and the constant is our y-intercept. This is a very, very useful way of graphing equations, because all we have to do is, if I put my coordinates, my axes on, then I start at my y-intercept, and in this case my slope is 3 over 4, so I go up 3 over 4 and connect those to make a line, and there's my graph. So slope-intercept form is a great way of graphing an equation. The next one I have is called standard form. Standard form is where the x and y are on the same side of the equation and the constant is on the other side of the equation. And the important part is the coefficients of x and y and the constant have to all be integers, so they can't be fractions or decimals. Okay, so it's ax plus by equals c, where a, b, and c are integers. A and b can't both be equal to 0, because then what you get is you'll get, like, 2 equals 5. So it's something that might be true or might not be true, but it's not an equation of a line. But you can have one variable, so you can have, like, y equals 5 or x equals 5, and we'll talk about those at the end. Okay. So the important part of this is x and y are on the same side of the equation, and no fractions or decimals for any of the constants or coefficients. Okay, so a lot of students think that standard form is pretty useless, but it's not. But if you're going to graph using standard form, you want to graph using intercepts. This one is a great way to graph for word problems, because a lot of time with word problems or something like that, your axes might be different, your scale might be different, and so figuring out the slope and then translating it into your scales can, a lot of times something we don't want to do. And with this case, all you're graphing is your intercepts, so you don't ever have to use the slope, which makes it really nice. Okay, so to graph this way, I'm going to actually write the equation again. So 6x plus 3y equals 12. First thing I do is I find the x-intercept. So the x-intercept is where y equals 0. Well, if y equals 0, then 3 times 0 is going to be 0, and this whole term is going to drop out. So what you end up getting is 6x equals 12, and if you solve that, x equals 2. So when y is 0, x equals 2, so my x-intercept is 2. And if I want to find the x-intercept, or sorry, the y-intercept, I'm going to do the same thing, except for this time, x is going to be 0. Okay, so the x-intercept is where y equals 0, the y-intercept is where x equals 0. And the same thing's going to happen if x is 0, 6 times 0 is 0, and this whole term is going to drop out. And you end up getting 3y equals 12, and y equals 4. And so my y-intercept is 4. Okay. Now, I wrote it out long ways. You don't need to write this out each time. The wonderfulness of this method is that you can really do it just by looking at the equation. If I want to find the x-intercept, I ignore the y term and I solve for x. And if I want to find the y-intercept, I ignore the x term and solve for y. And you can do that without writing anything down. Okay, notice I didn't draw my axes before I started, because I need to know where they cross the axes at before I put them on my grid. And so my x-intercept is 2, and my y-intercept is 4. And if I connect those with a line, there's my graph. So hopefully I showed you the usefulness, or if you already knew that, that's great, but if you didn't, the usefulness of that standard form, especially for graphing. Okay. And then the last form we have is point slope form. This form is very useful for writing an equation. And if something says to write an equation and gives me either a point and a slope or 2 points, most of the time I'll write it in point slope first, and then if I need it in a different form, I'll use math to get it to transfer into that form I need it. Okay, so for this one comes right from the slope formula. And so let me show you where it comes from, because it really helps me remember what the formula is. Okay, so if I draw any point on here, and so I'll call it x1, y1. Okay, so in order to use this, we have to know some point that is on the line, and you'll be given that point. And then what we do is say, well, any other point on that line, okay, and it could be any point, could be of the form x comma y. Okay, so the slope of this line would be, we would subtract the y's on top, and we would subtract the x's on the bottom. Okay? And then if I wanted to solve it for the y1 minus y, what I could do is multiply the x1 minus x to the other side, or multiply both sides by x1 minus x. And what I would end up getting is m times x1 minus x equals y1 minus y. And then if you use the transitive property, or sorry, symmetric property, what you end up getting is y1 minus y equals m x1 minus x, and that is just our point slope form. So if you can remember the slope formula, it really helps you remember, because the big part with point slope is remembering, does the slope multiply by the x's, or does the slope multiply by the y's? And if you can imagine the slope formula and then multiplying the x's to the other side, you can remember that the slope multiplies by the x's. Okay, so an example of this, if I want to write an equation, notice it doesn't say any form, it says write an equation. All I do is I do y minus the y coordinate, and then my slope, and then x minus my x coordinate. Since it's negative, it's going to be minus -1 or +1. Okay. Now, if it said to put it in a different form, so suppose it said to put it in standard form. So I'm adding to the problem. What I would have to do is I have to get rid of the parentheses, so I would distribute to get rid of that. Standard form, x and y have to be on the same side, so I'm going to subtract the 3x to join y. And I'm also going to add the 4 to the other side, and it'll join that constant. And then one little note, I will take this as an answer, it is acceptable, but a lot of times we like the coefficient of x to be positive. So a lot of times you'll see we'll multiply everything by -1, and we'll make it 3x minus y equals -7. We always want the things to look the same so that we can compare them. So by making the coefficient of x positive, it makes a nice way that we can compare lines to make sure that they are the same line. It's not incorrect to write the first one based on the definition of standard form, but most of the time you'll see the coefficient of x be positive. Okay, so this one will change up again. How about we'll make this an equation, but instead of being an equation, just any equation, we'll make this be slope-intercept. Okay. Now, a lot of you have done this by plugging in the slope and x and y and finding the y-intercept. That's fine, but I'm going to do it through point slope, and either way is correct. So first, I need a slope. So I'm going to take 3 minus -1, so 3 plus 1, and then -2 minus 1, so minus, and then I get 4 over -3. Okay, and then you can plug in either point. So how about I use the 1 -1? It seems easier. So I get 1 plus 1, or sorry, y plus 1, and then 4 over -3, and then x minus 1. Okay. So now if I'm going to put it in slope-intercept form, I need to distribute to get rid of the parentheses. negative times positive, so this is going to be positive. And then I have to subtract the 1 from both sides. So y equals 4/3 x, and when I subtract 1, that'll be 3/3, so this becomes 1/3. Okay. And if I use the other point, I will get the exact same answer for at least the slope-intercept. So I just want to quickly just show you that it does work out the same. So if I did use the y minus 3 equals negative 4/3 x minus 3, x plus 2. In this case, I would get y minus 3 equals negative 4/3 x, and then minus 8/3. And then I would have to add the 3 to both sides. And so I get y equals negative 4/3 x, and then add 9/3 to both sides. It's going to be plus 1/3. And I did notice on my other one that I did forgot to put the negatives. So that should be a negative, and that should be a negative. Sorry about the mistake. And you can notice that these are the same. I'm actually glad I did checked it, because you can see that they are the same. Okay. Now, if it says to write it as an equation, it doesn't matter if you use point-slope form, slope-intercept form, or standard form. But if it says to write the equation in a certain form, you can start out with, slope-intercept if you like slope-intercept, or point-slope if you like point-slope. But then you have to, your final answer has to be in the form it asks for. Okay. Horizontal and vertical lines are so easy. You just have to know what they are. Both of these have a special form. Okay, so there's no point-slope or standard form or slope-intercept form for a horizontal or vertical line, because each one of these only uses one variable. If it's a horizontal line, it's y equals a number, and if it's a vertical line, it's x equals a number. Okay. Now, a nice easy way to remember which one is which, if you take a look at the horizontal line, notice it crosses the y-axis. And so it's going to be y equals. And it's going to be y equals whatever that number it is that it crosses the y-axis at. So this is going to be y equals whatever this y-intercept is. And if you take a look at the x, or the vertical line, it crosses the x-axis. Okay? And so it's going to be x equals whatever that x-intercept is that it crosses the x-axis. So when I think about these, horizontal, I always think, what axis does it cross? Now, the horizontal line can run along the x-axis, but it's always going to cross the y-axis. So horizontal line is always going to be y equals. Vertical always crosses the x-axis, so it's going to be x equals. Okay, so for this problem, the horizontal line is going to be y equals, and then I just find the y-coordinate of the point. So y equals 2. And for the vertical, it's going to be x equals, and then I hunt for the x-coordinate, x equals 3, and there's my answer. And that's the end of today's video. Thank you for watching. Have a great day. Take care.